Okay, Bismillahirrahmanirrahim. We had started discrete probability distribution. This is chapter 6 of your book, and we solved few questions from discrete probability distribution. And now we are interested in solving some questions, and we want to have some idea of binomial probability distribution. Okay. Binomial probability distribution. Is it visible?
Yes, sir, it is visible.
Yes, sir.
Okay. The binomial probability distribution is widely occurring discrete probability distribution. Right? Now see the characteristics. Number one, an outcome on each trial of an experiment is classified into one of two mutually exclusive categories: success and failure. Okay, so basically by mean two. So when there are only two possibilities, one is success and the other is failure, then we normally take into our account binomial probability distribution. Second characteristic of this is the random variable counts the number of successes in a fixed number of times. Basically, random variable, we denote this random variable with x, and x counts the number of successes in fixed number of trials. We will see this inshallah later on, and we will solve some questions from this section. Then the probability of success, and failure stay same for each trial. I mean, if you are going to toss a coin, so probability, if you are interested in knowing the probability of occurrence of head, so it will remain same 50% even if you are going to toss a coin 1,000 times. Okay, so probability of success, if you are interested in occurrence of head, so that will be head. So x will be denoted by number of heads in tossing a coin. So if you are going to toss a coin once, 50% are the chances that head will be there, And similarly, if you are going to toss a coin 1,000 times, even then for each trial, the number of success, or you can say the number of heads will remain, the probability of number of heads will remain same as 50%. Okay, so probability of success and failure remain same over trials. Then the trials are independent. The trials are independent in binomial probability. That is, the outcome of one trial, the outcome of one trial does not affect the outcome of any other trial. So these are the characteristics of the binomial probability distribution. So now, uh, what is the formula for probability distribution? It is probability of x, capital X is equal to small x. It is equal to uh, ncx, ncx, p power x, and q power n minus x. Okay, so this is the formula for binomial probability distribution. So now I'm going to derive this formula. First of all, how you will have this formula. So derivation of binomial probability distribution. So you may start as let an experiment has n trials. Let an experiment has n trials, each of which may result in success. You can write down or denote success with S, or failure. Failure you can denote with F. The sample space has 2 raised to the power n, raised to the power n possible outcomes. Okay, if success and failure, these two are possible outcomes, then number of trials, if you're going to toss some coin, let us say once, so 2 power will be 1. You will take n as 1. And if you're going to toss a coin 10 times, so 2 power 10 will be the total, you can say, outcomes in that case. Okay. So now probability of zero success in n trials, probability of zero success or zero successes in n trials. So now let us see. Probability of X is equal to 0. What this means? No success, zero success. This is equal to probability of F, F, so on up to F. Or otherwise, you can write it as probability of failure multiplied by probability of failure, so on up to probability of failure. What this means? If the events are independent, if events are independent, as we had done in the case of multiplication rule. So special rule of multiplication, recall your memory. Special rule of multiplication in which we were saying that probability of A multiplied by probability of B multiplied by probability of C, in which we took probability of A intersection B basically. And then we said that the events are independent. So probability of A multiplied by probability of B. So in this case, if events are independent, so probability of F multiplied by probability of B multiplied by probability of F, and so on up to probability of failure. So everybody is getting failed. So therefore, the probability of success is if you multiply all failures, the probability of all failures, you will have the probability of zero success. Okay, remember events are independent. Now, if I say that probability of F is basically, I'm going to denote it with Q. So now if I say that probability of failure is equal to Q, then how will you change this equation? This equation then will become probability of X is equal to 0. It is equal to Q multiplied by Q multiplied by Q, and so on up to Q. So Q is there for n times. Q is there for n times. So you can write it as Q power n. If Q is there for n times, so you can take n as power of Q. Let us say if 2 is there for n times, so 2 power n will be there. Similarly, Q power n is there. Now see, if I say, what is the probability that there is only one success? So then you can write it as probability of X is equal to 1. And now probability of success and then failure, 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 and all failures are there. So only one success is there. And if there are n trials, out of n trials, there is only one success. It means n minus 1 are failures, and only one success, S, is there. So now if again events are independent, then you can write down probability of S multiplied by probability of F multiplied by probability of F, and then so on. Final term will be probability of F failure. Fine.
एक्सक्यूज मी सर.
Yes, boy.
सर यहाँ में जो प्रोबेबिलिटी ऑफ एक्स है इसका मतलब सक्सेस है.
Yes, probability of S means probability of success. Okay.
ये
So
एक्स इज इक्वल टू 1 इसका मतलब ये एक वन सक्सेस है.
yes, X is equal to 1 mean number of successes. How many number of successes are there? Only one. So if there are n trials, so out of n trials, there is only one success, remaining are all failures.
सर
Yes.
सर अगर उस फेलियर को शो करना हो तो फिर उसके लिए क्या करेंगे? उसके लिए भी अगर फेलियर फंस के एक मरतबा है तो हम उसके लिए क्या x इज इक्वल टू 1?
Yes, if you're interested to write down, if you are going to say that there are, basically you have to define the event. I am defining the event as X is the number of successes. Okay. And I am going to denote success with S. If you are going to denote success with F, so it's upon you. You can write down F as success. Okay.
No, sir.
But that will be of little confusion. F is better to use for failure and S is better to use for success. Okay. So
और
now
मैक्सिमम
PS, probability of success, I'm going to denote it with P. So let us say P is equal to probability of success. So I'm going to denote, as I had denoted, probability of F is equal to Q. Now I'm going to denote probability of success equal to small p. So P, and then if you see probability of F, I'm going to say that it is Q. So Q is there for n minus 1 times, because the total trials are n. One is as success, the remaining are n minus 1. So now Q power, the power of Q will be n minus 1. In this case, if you see Q power n, why? Because all were failures. Q from 1, 2, 3 up to Qn. So all were failures. Therefore, I wrote here Q power n. But now there is one success. So one success is out. That is, I'm going to denote with P. So one P is out. So remaining trials are n minus 1. So you write it down as this. So one success is equal to probability of success multiplied by probability of failure raised to the power n minus 1. Then you can write down over here the probability for any possible sequence. The probability for any possible sequence consisting of one S and n minus 1 failures and n minus 1 failures can occur in NC1 ways. NC1 ways, combination formula, NC1 ways. Therefore, the probability of exactly, therefore, the probability of exactly one success for all possible sequences combined is. So now basically what this statement is explaining, the probability of any possible sequence consisting of one success and n minus 1 failures can occur in NC1 ways. NC1 ways. This could occur in NC1 ways, the combination formula. Counting principles, recall that. Okay. NC1 ways. So how can you write it here? You can write it as probability of x is equal to 1. It is equal to NC1 P power 1 and Q power n minus 1. So basically, if you see, we have proved up to this point that probability of x is equal to 1, P into Q raised to the power n minus 1. But how many ways this could occur? NC1. NC1 are the ways in which this situation may occur. So therefore, we are going to multiply this with NC1. So NC1 is equal to this. So now, initially we checked it for 0 success, and then we checked it for 1 success. And if I say that I am interested in having the formula for x successes, small x, then this formula will take the shape capital X is equal to small x. And now you simply will change 1 with x and p with x and q with n minus x. So this is the formula basically. That is the binomial formula. We call this binomial formula. Fine. So this is your binomial formula, and this is very useful formula. If you see the case where we normally have a plus b power 2. So we normally know that it is equal to a square plus b square plus 2ab. So we can have this equation using the binomial formula. How? Let us see. If you take this a as p and this b as q, so take in that sense, then how will you start? Let us say n is equal to 2 in this case. So you will start from 2c0. A power will be 0. And b's power will be 2 minus 0, that will be 2. Plus 2c1, a power 1, and b power 2 minus 1, that is 1, plus 2c2, a power 2, and b power 2 minus 2, that will become b power 0. Okay, so now if you further expand it, 2c0 mean 1, 2c0 mean 1, you can check it. A power 0 mean 1, b square will be there, plus 2c1 mean 2, a and b, plus 2c2 mean 1, b power 0 mean 1, so you will remain with only a square. So now you can see that this is exactly this. Simply you can write down the terms if you are interested in writing down a square, so you can write down over here a square plus 2ab plus b square. So these two are equal. Similarly, if you are interested in finding out a minus b square, so now you will take b as minus b. Let us say I'm going to write it as a plus minus b whole square. So you can write it down in this way. So now again 2c 0, you will start from 0. You will take x value 0 first, and then a power 0, and then minus b power 2 minus 0, that will be 2, plus 2c1, a power 1, minus b power 2 minus 1, that is 1, plus 2c2, a power 2 and minus b power 2 minus 2, 0. So now when you will further solve it, 2c0 mean 1, a power 0 mean 1, minus b square mean b square, positive sign, minus 2ab, and then plus a square. So in this way you can have the answer. This is square. This is square. Fine. Similarly, if you are interested in finding out a plus b cube, so you can solve it as 3c0. You will start from 0, 3c0, a power 0, and b power 3 minus 0, that will be 3, plus 3c1, a power 1, b power 3 minus 1, 2, plus 3c2, a power 2, b power 3 minus 2, 1, plus you will write down the final term as 3c3, as you wrote in the previous case. You finished it at this point 2c2. Similarly, you will finish it at 3c3 a cube, and b 3 minus 3, that will become 0. So now you can open it. 3c0 is 1, a0 1, b cube plus 3c1 is 3, 3ab square will be there, plus 3c2 is 3, so 3a square b, plus 3c3 is 1, b power 0 is 1, so you will remain with a cube. So are you understanding what I am doing? I am basically giving you the
Yes,
idea
sir.
that by using binomial formula, you can find out different formulae. So now you can write down, you can transform this equation as a cube plus b cube plus 3ab into a plus b. So this is the formula. So you can find it in this way. If it was negative sign, if it was a minus b, so you can solve it as writing down minus b in this way. So you will have some equation using that. Clear?
Yes, sir.
सर अगर इसको टेबल की फॉर्म में लिखा जाए x1 x2 x3 का एक कॉलम हो और बाकी ऐसे साथ पुट करते हैं वो नहीं
Sorry?
सर टेबल की फॉर्म में अगर लिखें तो वो ठीक नहीं रहेगा
Tabulated form?
सर के एक कॉलम हो प्रोबेबिलिटी का दूसरा x का और तीसरा फार्मूले का हो तो उसमें हम पुट करते हैं साथ साथ
So it's upon you. You can write down in that way, no problem. It's upon you. Basically, we want to explain the idea that this is the binomial formula that we have derived, and now we can use this formula in different ways. Okay. So now, let us solve an example. Let us solve an example. A fair coin is tossed 5 times. 5 times. Find probability of various number of heads. Find probability of various numbers of heads. Various numbers of heads. So how can you find out? There are 5 trials, 5 tosses. Fair coin is tossed 5 times. So you will start solving this question as, you are basically interested in heads, number of heads. So you can define your heads as successes. Okay. So let X be the event that head is there. Okay. Then probability of, so X is basically number of heads, successes. So probability X is equal to 0. X is equal to small x, and small x is equal to 0. So capital X is equal to 0. What this means? This means no head. So it is quite possible that you tossed a coin and there was no head. Tail was there basically. So how will you write it down? 5C0, because total 5 tosses are there. So 5C0. What is probability of success in this case?
0 sir
50%. 50% are the chances that head will be there. So probability of success is 50% in tossing a coin once. So this probability will remain same over several trials. So now you will take 0 power of this. And then for failure, what is the probability of failure? Means what is the probability of tail? That is again 5, 50%, 0.5, 50%. So now 5 minus 0, power 5 will be there. 5 minus 0. 5 minus 0 means 5. So 5C1 is 5, 5C1, sorry, 5C01, and any digit raised to the power 0, that is 1. So 0.5 power 5. So what is the answer? Let us see. What is the answer? What is this? 0.5 raised to the power 5.
03125.
Point zero three
Point
one two five.
0325.
03
125.
125.
125.
Yes, sir.
So
Yes,
you can
sir.
write it as 0.0313 up to 4 decimal points, right? Then there will be probability of occurrence of one head. So you can solve it. It will become 5C1, again 0.5 power. Now it will become 1, and 0.5 power 5 minus 1. So that will become 4. So you can solve it. So it will become basically 5 power 6, 0.5 power 6. What is the answer? Point 1563. Fine. So then you will move onward. You will check it for x is equal to 2. You will check it for x is equal to 3. You will check it for x is equal to 4. 4 means you tossed a coin four times, and 4 times there were heads. And finally, maximum number of tiles are 5. So it is quite possible that you toss a coin 5 times and all 5 times you obtained head. So what is the probability for that? X is equal to 5. So in this case, uh, it will become 5C5, 0.5 raised to the power 5, and 0.5 raised to the power 5 minus 5, 0. So you will have the probability as 5C5 is equal to 1, and 0.5 power 5. It will be same as you obtained this 0.0313. 0.0313. So you can use your calculator to find out all these. Right? Okay. So now I'm going to solve an example here. See, the probability that the probability the probability that any flight arrives late any flight arrives late is 0.20. There are total 5 flights. There are total 5 flights daily arrive at Islamabad airport. You can say Karachi. Now, what is the probability? What is the probability that none of the flights are late today? This is one question. Then what is the probability? What is the probability that exactly one of the flights is late today? So this question you may confront with. So how will you solve it? Yes. Now, first of all, you will see that what is the probability of success in this case. You have to define it. You have to define it, that what is the probability of success in this case. So see the question. The probability that any flight arrives late is 20%. So late arrival is the probability of success in this case. Late arrival is probability of success in this case. So I'm going to denote that with P. So probability of success, P is 0.20, late arrival. So Q will be, you will use the complement rule. And according to complement rule, the sum of probability is always equal to 1. So P plus Q is equal to 1. So Q will equal 1 minus 0.20. So this will be equal to 0.80. So what this means, Q? Arrival exactly on time, 80% are the chances. And late arrival, 20% are the chances. So now you have to see that how will you answer this question. What is the probability that none of the flights are late today? None of the flights are late today. It means X is equal to 0. You are interested in finding out probability of X is equal to 0. None of the flights are late. So now use binomial. So basically, why are you interested to use binomial? Because there are only two possibilities. We have written this in the characteristics of the binomial probability distribution, that there are only two possibilities: success and failure. So in this case, if you see whether the flight will be in time, the arrival will be on time, otherwise it will be late. So there are only two possibilities: late or not late. So therefore, we will use the take help of binomial formula. We take help of binomial formula. So in this case, what is n? So for n, you have to see this information. Total 5 flights are there. Total 5 flights are there means n is 5. So you will start from 5. 5 C 0. You will start from 0. 5 C 0. P raised to the power 0. What is P? 0.20. Raised to the power 0. Multiply by 0.80. Raised to the power 5 minus 0, that is 5. So when you will solve this, you will have that this probability. What is the probability that none of the flights are late today? None of the flights, 0. X is equal to 0. Simply substitute 0 here. 5C0, 0.20, power 0, 0.80, power 5. 5 minus 0 is equal to 5, so therefore I'm just writing here 5. So 5C0 is equal to 1, 0.20 power 0 is equal to 1. So you simply have to take 0.80 raised to the power 5. See what is the answer.
Point three
Point three.
two seven seven.
So what is the answer?
Sir, 0.3277.
0.3277. So this is the uh, probability, or otherwise you can say 32.77% are the chances that none of the flights are late. Okay. So the next question was, what is the probability that exactly one of the flights is late today? Exactly one. So now you will write down here probability of X is equal to 1. Exactly one is late. So now NC1, so 5C1. P was 0.20 and Q in time arrival, that is 0.80. So this one You write down over here, and 5 minus 1 is 4. So when you solve it, see what is the answer. Yes, what is the answer?
0.4096.
0.4096. Okay, so similarly, you may move onward, but as you see, only two questions are there. But if you are interested in knowing that what is the probability that exactly two flights were late, exactly three flights were late, exactly four flights, five flights were late, so you can write down the distribution, the probability distribution, right? So you can also write down this in form of table also. Okay. So now we can also solve another question. See. Example, 80% of the employees of firm receive their wages directly in their bank accounts through electronic funds transfer. Suppose we select a random sample of 7 employees. Does this situation fit the assumptions of binomial distribution? What is the probability that all 7 employees receive their salaries directly? What is the probability that 4 of 7 selected employees receive their salaries directly? So you may confront with such questions. 80% of the employees of a firm receive their wages directly in their bank accounts through electronic funds transfer. Suppose we select a random sample of 7 employees. So does this situation fit the assumptions of binomial distribution? This was the first question. What is the probability that all 7 employees receive their salaries directly in their bank accounts? And then there was a question that what is the probability that 4 of 7 selected employees receive their salaries directly? Okay. So what is your opinion? Does this situation fit the assumptions of binomial distribution?
Yes, sir.
How? There are only two possibilities. One is that the salary or the wage is being disbursed in form of cash. Okay, so you are going to receive cash in hand. Otherwise, you have your salary in your account. So there are only two possibilities. You can have it in form of cash, or otherwise you may have in form of funds transfer in your account. So there are only two possibilities. So in case of binomial, we have only two possibilities. So therefore, this situation fit the assumptions of binomial distribution. Right? What is the probability that all 7 employees receive their salaries directly in their accounts? So now receiving salary in the account, this is the probability of success, and that is given 80%. 80% of the employees are having their salaries in their accounts. So 80%. So P, small p, probability of success is 80%. So now you can solve it in this way. All 7 are receiving salary in their account. So X will equal 7. Total are 7. So 7C 7. 7C 7. And what is Q? Q is
0.2.
0.80. 0.80 power 7. And 1 minus 0.80, that is 20%, or 0.20, and 7 minus 7, so 0 power will be there. So this will be the required probability. What is the probability that all 7 employees receive their salaries directly in their accounts? So 0.80, 80% are the chances that employees have their salaries in their accounts. So therefore, this is small p, 0.80. And probability of failure is that they are receiving cash. Okay. So 7C7 will become equal to 1. This 0.20 power 0 will equal 1. And so you simply have to take the 7th power of 0.80. Let us see what is the answer.
0.2097.
0.2097. So you can say 20.9% are the chances that all 7 employees are going to get their salaries in their accounts. Right? So now come to the last question. What is the probability that 4 of 7 selected employees receive their salaries directly? So in this case, if you see 4 of 7, so it means that X is equal to 4 now. Total employees are 7, C4, 0.80, power 4, and 0.20, power 7 minus 4, that is 3. So you can solve it. Yes, what is the answer?
0.1147.
0.1147. Okay, so 11.47% are the chances that 4 out of 7 will have their salaries in their accounts. Right? So now I am confident that you can solve all similar questions if you confront with. Right? So now there comes cumulative binomial probability distribution. Cumulative binomial probability distribution. So what is this? We basically cumulate the probabilities. Okay. So in this case, you can solve any question. Let me solve one question for you. In recent study, 80% of homes in Islamabad were found to have large sorry, LEDs. Light emitting diodes. Basically, these are the TV sets. Okay. In sample of sample of 9 homes, in sample of 9 homes, what is the probability that all nine have LEDs? All 9 have LEDs. Less than 5 have LEDs. Basically, this apostrophe should not be there. LEDs, in this way you can write it down. LEDs. LEDs. Less than 5 have LEDs. Then there may be a question, what is the probability that at least 7 have LEDs? So these 3 questions may be there. So there may be so many questions like this. Okay. So now we are basically discussing cumulative probability distribution. So in recent study, 80% of homes in Islamabad were found to have large LEDs. So in this case, having LED is probability of success. Having LED is probability of success, and not having LED is probability of failure. So all 9 have LEDs. So how will you solve it? So basically you have to see that there are only 2 possibilities. LED is there, LED is not there in the home. Okay. So binomial probability distribution, and in this case all 9 have LEDs, so probability of X is equal to 9 in this case. Probability of X is equal to 9. All 9 have this. So how will you solve it? Simply, how many total homes are there? 9. So 9C9. 9C9. What is probability of success in this case? 80% have LEDs. So 0.80 power 9 multiplied by 0.20, the probability of failure not having LED. So power 9 minus 9, that is 0. Okay. So 9C9 is 1. 0.20 power 0 is 1. 0.80 power 9. You simply have to solve this. 0.80 power 9. See what is the answer.
0.1342.
1342.
1342. So 13.2% are the chances that all 9 homes have LEDs. Now less than 5 have LEDs. So accumulation you have to perform over here. Less than 5 have LEDs. So first of all, how will you write it? Probability X less than 5. You will write it down in this way. N, probability of X less than 5. Less than 5 have LEDs. Okay. So now you can solve it in by using 2 roots. Okay. One root is this, that you simply take into your account this. You can write it down as probability of X is equal to 0 plus probability of X is equal to 1 plus probability of X is equal to 2 plus. So you are going to accumulate the probabilities. So therefore cumulative probability distribution. Probability of x is equal to 3 plus probability of x is equal to 4. And you have to stop over here because x is less than 5. See, x is less than 5. So you will stop at 4. So how many terms are there? 1, 2, 3, 4, 5 terms are there. So you can solve these 5 terms to have the answer. This is one root. This is one root. So let us solve this. See what is the answer. So you will start from NC0. So what is N? 9 ohms are there in total. So you write down 9C 0.80 power 0 multiply by 0.20 power 9 minus 0, that is 9. So 9 will be there plus 9C 1.80 power 1.20 power 9 minus 1, that is 8. So further when you will go plus 9C 2.80 power 2 into 0.20 power 9 minus 2, that is 7. That is 7 plus 9C3.80 power 3 multiply by 0.20 power 9 minus 3, 6. Further plus 9C4, and this is the last term, 0.80 power 4 into 0.20 power 9 minus 4, that is 5. So see what is the answer. So you have to solve this. Anybody?
सही है, सारे को इकट्ठा सॉल्व करना है.
Yes, one by one. You can solve it in 2 steps, or otherwise, if you are familiar with your own calculator, so you can give some braces and you can give some commands to your calculator, and you can have the answer only in one step. So it's upon
Yes, sir.
you. So it is not difficult. 9C0, it will become equal to 1.80 power 0. This will become equal to 1. So you simply have to take 0.2 power 9 and then write down this and then plus 9C1. So you can solve it, I think. It is not that difficult.
Yes.
Yes, Wade, what is the answer? Quickly, boy.
तो सॉल्विंग के बाद कर सकते हैं.
Yes.
भी करें.
Yes, if you have a calculator with you, you must solve it. Otherwise, I'm going to give you the answer. I have solved it. 0.0195. 0.0195 is your answer. Right? So you can find out the answer in this way. Otherwise, this was the one route that you can adopt. The other route may be you can also have probability of x less than 5. Okay, so you can also write it down as 1 minus probability of x greater or equal to 5. Okay, so these two are equal. Fine. You know, basically there are 3 possibilities: equal to, less than, or more than. See, these are the 3 possibilities: less than, equal to, or greater than. So if you add all these 3 possibilities over here, you will have the answer as 1. So let us see if I write it down as probability of x less than 5. So up to 4 terms will be there, plus probability of x greater than or equal to 5. So the remaining 5 up to, if there are 9 samples, so you may go up to 9. So all 9 will be covered equal to 1. So probabilities of all these, all probabilities, the sum for these probabilities will equal 1. Okay. So if you see this, up to x is equal, from x 0, 1, 2, 3, 4 will be covered by these probabilities. And from 5 up to the given number of total trials will be covered over here. So if n is equal to 9, x will become equal to 9. So 5, 6, 7, 8, 9 will be covered in this probability. So when you will add all these probabilities, you will have answer as 1. So you can adopt this route. Simply you can start from 0, as it is x less than 5, so up to 4. These 5 terms will be there. And if you are interested in using this route, then how will you take it? How will you solve it? So you can solve it in this way. This will equal 1 minus braces, and now you will start from probability of x is equal to 5 plus probability of x is equal to 6 plus probability of x is equal to 7 plus probability of x is equal to 8 plus probability of x is equal to 9. So now again you use the formula NC5, so 9C5 0.80 power 5. So you will use this strategy. Okay, and finally when you will calculate all these and you will subtract the answer from 1, you will have the same answer, this answer. You will have this answer 0.0195, exactly this answer. So by using both strategies, you will be at the same destination. Fine. Then there is a question, the final question. At least 7 have LEDs. At least 7 families have LEDs. So for at least, you have to write down it as x greater than or equal to 7. So this is for at least. Remember, this is for at least. And if there was a question that what is the probability that at most 7 have LEDs, so then you will write it down as probability of x less than or equal to 7. So this is the probability when you are interested in the situation of finding at most. So remember it, greater than or equal to 7, less than or equal to 7. So this is for at least and this is for at most. So now first of all, if you are interested in solving this, how will you solve it? Probability of x greater or equal to 7. So now again you can take into your account 2 routes, but you have to have that route that is in which you have to use fewer terms. Okay, so fewer terms will be there if you take into your account this strategy, greater than or equal to 7. So 7 is there, 7, 8 and 9, 3 terms will be there. Otherwise, if you use this strategy, 1 minus probability of x less than 7, so now you will start from 0, so x 0, 1, 2, 3, 4, 5, 7, so 8 terms will be involved. So avoid this route. Better would be if you use the other route, and that is very simple. Simply write down 3 terms. What are those 3 terms? Probability of x is equal to 7. Okay, plus probability of x is equal to 8 plus probability of x is equal to 9. So you can simply find out using this strategy. Fine. So this is the case where you are interested in finding out at least 7. So similarly, if you are interested in having at most ज़्यादा से ज़्यादा 7 हैं जिनके घर में टेलीविजन है, so then you will write it down as x less than or equal to 7. And now if you take the straightforward strategy in this case, so you can start from 0 and you will stop at 7. So it means that 8 terms will be involved. So better would be if you use this strategy, 1 minus probability of x greater than 7. So now greater than 7, there will be only 2 terms, 8 and 9. So instead of writing 8 terms, you can simply use this strategy. And in this strategy, you will have x is equal to 8 plus probability of x is equal to 9. So only 2 terms will be involved and you will have the answer. So let us see what is the answer. 1 minus, so probability of x is equal to 8. What is NCX? So 9CX, x is 8. So you write down here 9C8. What was x? 0.80. So write down as 0.80 or 0.8 power 8 multiply by 0.2 power 9 minus 8, that is 1, plus 9C9, 0.8 power 9 and 0.2 power 0. So see what is the answer and then subtract it from 1. What is the answer? See what is the answer. 9C8 is equal to 9. So 9 multiplied by 0.2 multiplied by 0.8 power 8. This is 9C9, 1, 0.2 power.
538.
Sorry?
0.5638.
0.5638. And have you subtracted that from 1?
Yes, sir. Yes.
So I think there is a problem. There is some problem because I have some other answer.
No.
So let me calculate it again. 9C8 is 9. 9 multiplied by 0.8 power 8. 0.8 power 8. Let me do it again. 9C8. That is 9. Multiply by 0.8 raised to the power 8. Multiply by 0.2. So you will have over here 1 minus 0.3019 plus 9C9 is 1 and 0.8 power 9 you will have to calculate 0.8 power 9. So it is 0.1342. So now add plus 0.3019 and now subtract it from 1.
सर ये माइनस में आ रहा है
So,
-5.
no. It will be positive, not negative.
सर वही वाला आंसर है जो मैंने बताया.
Which answer?
0.5639.
0.5,
639.
6, 3,
सर अगर हम माइनस 1 माइनस ना करें तो फिर ये आता है आंसर. अगर हम 1 माइनस करें तो फिर ये आंसर माइनस में चला जाता है सर.
No, probabilities are never negative. Probabilities are never negative. Remember it. You are wrong. Answer will be positive. Fine. So you have to calculate it. All of you must be able to solve this using your calculator. Fine. Clear?
Yes, sir.
आप इसको दोबारा करें उसामा. 9C8 is equal to 9.
सर कह रहा हूँ दोबारा.
Multiply by 0.8. 0.8 raised to the power 8. Whatever is the answer, multiply that with 0.2. So you will have 0.3019. And then you have to add this in. 9C9 is equal to 1. 0.2 power 0 is equal to 1. So 0.8 power 9 that you have to take. So it will become 0.1342. Now you have to add in this 0.3019. The answer is 0.43611. You have to subtract this from 1. So the answer is
यस सर
0.5639.
ये
Right?
सर अगर वो 1 माइनस ना करे तो वो आपको जो आंसर सर कह रहे हैं 0.4361 वाला वो तो आता है सर.
So basically it's upon you. You can take this strategy because only two terms are involved in this case. But if you are going to write down this as using the other strategy, then probability of x, see, less than or equal to 7, less than or equal to 7. So now in this case, the other strategy is probability of x is equal to 0. You will start from 0 plus probability of x is equal to 1 plus so on. You will use and you will stop at probability of x is equal to 7. So it means that 8 terms will be involved. So when you will find out the answer for these 8 terms, that answer will be exactly same as this. So there is no need of taking into your account 8 terms. You have to use that way. In using that, you have to use minimum number of terms involved. So here in this case, only 2 terms were involved. So therefore, I prefer this strategy. Whereas in this case, if you see, 1, 2, 3, 4, 5 terms are involved. Okay. Otherwise, you can also take into your account the other way, and in that case, you will start from let us say less than 5. So you will start from 0, 1, 2, 3, and you will stop at 4. So it's upon you. You can use any way to find out the answer. Okay. So now you are recommended to solve some other questions from this binomial probability distribution. One thing more, and that is the mean and variance in this case, as we found in case of discrete probability distribution that the mean was what was the mean in that case? X into px summation. If you recall the discrete probability distribution, what was the average formula for average? This was the formula. And what was the formula for variance in that case? That was summation x minus mu square into probability of x. So you have to solve some questions from this also. Okay. So this was the two formulae, mean and variance, when we were discussing the discrete probability distribution. And now when we are specific with binomial probability distribution. So in this case, if you are interested to find out the average or mean, then mu will equal NP. NP. This is the formula for mean. And what is the formula for variance? That is NPQ. NPQ is the formula for variance. We can also prove this formula, no problem. If you are interested in proving this formula, we can also prove it. But better would be if you just remember this formula. This will help you in finding out the variance and the average. Okay, so let us say what will be the mean in this case that we are just solving. So you will take into your account n are 9. Okay, and p is 0.80. So if you are interested in finding out mu, so simply multiply Nine
7.2,
9 with 0.80.
7.8, 7.2, sir.
7.2. So you can say that on average, 7.2 homes have LEDs. What is the variance? Simply multiply this as 0.80 multiply by 0.20. See what is the answer.
1.44.
1.44. 1.44. So this is the variance. So you are familiar with the concept of variance. Okay.
Yes, sir.
So in this way, you can find out mean and variance. And if you're interested in finding out standard deviation, so you will simply take the square root of variance. So standard deviation in this case will be standard deviation. Simply take square root of 1.44. See what is the answer.
1.2.
1.2. So this is standard deviation. Fine. So this is all for today. And inshallah, meet you on Thursday, coming Thursday, inshallah.
And
Thank you
किस
very
time
much for
Thursday?
your patience. Thank you very much for your patience.